All right. Lesson number 14. Don't want to disappoint you here, people, but really the only thing that we're doing here is plotting on a coordinate plane. Ooh, that got a little messy there. Let's read it there. So all we're going to be doing now here is, again, we're looking at three different ways of presenting our information. It's one of those things of where you're going to choose one over the other, but again, we do want to kind of see what we've got going on here. So that's what we got here. We got Kelly here. She's traveling by train with her soccer team from Yonkers, New York, which is an actual place. Funny to say, but it is real, to Morgantown, West Virginia for a tournament. The distance between Yonkers and Morgantown is 400 miles. All right. The total trip will take 8 hours. The train schedule is provided below. Okay, so there's all of our information that goes through it. We want to create a table to show that the time it will take Kelly and her team to travel from Yonkers to each town listed in the schedule, assuming that the ratio of the amount of time traveled to distance traveled is the same for each city. Then extend the table to include the cumulative time it will take to reach each destination on the ride home. Okay, so starting with hours there, okay, it's going to take 1 hour, all right, and we're trying to figure out. So let's go back up here. We got 400 miles. It's going to take, total trip will take 8 hours. So the idea here is if we look at our original piece of information, we've got 400 miles to take 8 hours. So for 8 hours, let me get back here, for our 8 hours to 400. So we always talk about finding the value first. So if we divide by 8, I notice that 8 is going to fit into 40. So 8 divided by 8, that's going to give me 1. And then 40 divided by 8 is 5, but I still have a ones place, so I've got 1 to 50. So for every 1 hour, it's going to be 50 miles. So for 2 hours, now we're at 100 miles. So what that lets me know here is, in 2 hours, this is when we're going to get to Allentown. And again, I can see that because it takes 100 miles to get there. And then I can kind of fill in here 3, 4, 5, 6, 7, 8. And then we can see here, okay, figure out your pattern here. So we could do the repeat addition because I'm in order here, so we could go along with it. I know we said we don't really like to use repeat addition, but when we're creating the entire table, that's okay. That's not as bad as when we're jumping around. I know I've kept a pattern, so that's why I'll keep a pattern here. So then I can see here, 200 miles. Oh, hey, this is Carlisle. Okay. And the idea here is now 400 miles is, let me see what I've got here. Oh, I'm sorry, I missed 300, Berkeley Springs. All right, Berkeley and then Springs. And then 400 miles to get to Morgantown. So the idea here is I did create the table, all right, time traveled to distance traveled. I used the value like we always been talking about, and then extend the table to include the cumulative time it will take to reach each destination on the ride home. Well, the whole idea behind that is if we're going to get right back, we're just going to see it going the opposite direction. So we can see here that to get from Beverly Springs to Morgantown, it took 2 hours. So if we want to keep the table going here, we could jump right to 10, and then we can say we're right back at Berkeley Springs. And again, that's 200 more miles, so that's 600. And then we could see that, okay, it is, all right, oops, I'm sorry, it's 100 miles. So let's change that. All right, to get from Morgantown to Berkeley Springs, it's 100 miles. So now we're at a total of 500 miles that has been traveled. And then to get from Berkeley Springs to Carlisle, it's another 100 miles. All right, another 100 miles. But we can see here is I've changed the pattern. Now I'm going up by 2 hours. So that's why it's a 12. So again, you just can't go into autopilot mode. You got to we got to watch what you're going on here. So we got 800, and that's going to give me a total of my 16 hours then. So that did extend the table to the cumulative ride. So the main thing here is filling out your table. If we're counting by ones, that's fine. We can keep the repeated addition here. But when we make that change, like we did from 8 to 10, we just can't keep our same pattern going. We do have to be careful about that. Okay, so the idea here is create a double number line to diagram this to show the time, they would take calorie per time. So it's the exact same thing all over again, except they want you to show it on a double number line. So they're just showing that, listen, if you had if you want to start with 0 hours with 0 miles, so this is our hours, this is our miles, and you saw from the table we had 1 hour, all right, got us to 50 miles, and then our 2 hours got us to 100 miles. So we could continue filling it in, just going left to right. Again, it's the same idea. Using the double number line, how many miles would be traveled in 1 hour? Well, we can see right there, all right, that it would be 50 miles. How do we know? All right, well, we found the value. All right, that got things started. So by finding the value, we were able to simplify it down to the very beginning of how much it was for one. But again, I'm not too much of a fan of that particular question. How do you know? Well, again, I guess my percentage is what did you do to figure out 1 mile? I think that's a better idea. Okay, so dinner service starts once the train is 250 miles away. What is the minimum time the team will have to wait before they can have their meal? Sorry, I had some page editing issues there that I wanted to take care of. So back to when is dinner, because this is what we always want to know. So the whole idea here is we can take our information and then plot it to get a visual of what's going on. Again, it's the same idea. It's to figure out what's going on in between them. So if we're at 1 hour, all right, we know that we were traveling 50 miles. All right, at 2 hours, we were at 100 there. Now, here's what I'm going to do is traditionally we just keep going right down the line there. Okay, and well, let's just go ahead. 3, 4, 5. All right, 50, 100, 150, 200, 250. All right. So dinner service can start once the train is 250 miles away from Yonkers. So we can see right away. Hey, look at that. The answer is 5 hours. Okay. The whole idea is we want to show you that if you didn't use these particular numbers, okay, then you can use the graph to see what's going on in between. So let's see what we've got here. Miles and we've got hours. Excuse me, we got miles and we've got hours. Okay, so typically time is always going to be on your bottom axis, which is our x-axis that we are dealing with here. So this is, what kind of label there? So we're time, so this is in our hours. Now, as you can see, they're really small. So what I'm going to choose is kind of a different scale to kind of give an idea of what's going on with it. And so this is our miles that we've got here. So I'm going to go 1, 2, 3, 4. All right, that's going to make 1 hour. And then 1, 2, 3, 4, 2 hours. 1, 2, 3, 4, 3 hours. 1, 2, 3, 4. All right, 4 hours. 1, 2, 3, 4. There's 5 hours there. What we can end up doing here is plotting our points. So we can use them as hours and miles. So if we graph each of them, and all we're doing here is using our hours and our miles to make our ordered pairs. All right, then 200, and then 5 with our 250. Get that in there. And again, all I'm doing is taking these guys that are here. That's it. And then all we're going to do now is we're going to graph, but I got to figure out what I'm going to count by here. So I'm going to go for hundreds here. I'm going to go 1, 2, 3, 4, and again use 100. 1, 2, 3, 4. All right, and now use 200. 1, 2, 3, 4, and then a 300. I'm trying to get my spacing a little bit, but I'm being consistent here. 1, 2, 3, 4. All right, 400. 1, 2, 3, 4. All right, 500. And I'll stop there. So the idea is if we went to the right, I want to go up, all right, to the right 1 hour, but I want to go up to 50 miles. Now, this is my 100 marker, so 50 would be right in between it. So there we go. And then 2 and 100, I'm going to right 2 hours, and I'm going up to 100, and then going to the right to 3 hours, all right, and then I'm going up to 150. Now, again, how do I know 150? Well, that's directly in the middle of it. I don't know why I get the disappearing kind of papers the dots there sometimes. All right, so then 4, and I'm going up 200. All right, and then I'm going to the right 5, and then I'm going, oh, where did you go? Frustrating day here, people. Frustrating day. 5, and then up to the 250, which is going to go in the middle there. So I think that's good. Okay, so the idea now is we can connect, and we knew 0, 0, so we can even put that in there. We can go ahead and connect our dots. And the idea is yes, it landed on it perfectly. Okay, so what's the minimum time? Yeah, 5 hours. And we can see here, because that's 250 miles away based off this, it's easier to see from the table. Where this gets interesting is let's say it wasn't 250 miles. Let's say it was 135 miles. Well, then we could get an idea of where 135 is, and we go, okay, that's 150. Okay, so it's somewhere here, so it would be less than an hour. So that's where we start using is when stuff's going on in between. The table's nice when it lands right on it. Right on the answer. Okay, but, all right, oops, I'm sorry, yeah, that's a 250 that we've got there. But when it doesn't land on it nicely, what are we going to do? Well, double number line is a nice thing to find who's on between. And let's say I didn't say 135. Let's say I ended up saying 215 miles. So then we go, okay, 215 just to pass 200. So let's just pass 4 hours. So we would say then around 4 hours. And again, we'd have to look what the question's saying is, do they want an approximation? What are they looking for? Listen, I figured that Narwhal song was stuck in your head the entire time, so that's why I didn't play anything else. So it only makes sense to finish with it.